Okay, rational and irrational numbers, is that familiar to you, or is that like I've never seen it before? Have you heard of this before? Heard of it? Okay. I don't know if you've seen this or not before, maybe in elementary, if you got a really, really good teacher. There's rational and there's irrational. Okay, let's just follow this along. Convert that to a decimal. Don't laugh. Some of us don't know how to do this. Do you have a calculator? Then you put it in. That's how you do it. Okay? 28 divided by 11. That's what it says. On. And is that going to give us a decimal? Yes, it does. 2.54545454. I sure wish my pen would stop being crazy. Okay, we get the picture. 54545454. That decimal's doing something. Does it end right there? Just because your calculator only gives you 8 or 9 digits doesn't mean it stops. I think we can come to the conclusion that goes on forever and ever and ever and ever. That's why I'm writing the dots here. Okay? 3 dots is usually all we need. That means it doesn't stop. It doesn't. Here's a different word for stop. You know why? Because it's rounding the last part. Ignore that. It doesn't stop at 6. It's 54545454. We denote that by putting a line there. That means repeat. Okay? Circle the correct alternatives. This decimal, that, does it repeat or not repeat? It's repeating. Okay? Does it terminate? Terminate means stop. Okay? Or does it not stop? It does not terminate. Does not stop. Okay? Let's look at a different example. 28 divided by 8. What's that? $28 over 8, 3.5. Do you think that one stops? Yeah. Terminates? Absolutely. It's exactly 3 1/2, otherwise known as 3.5. All right? Does it repeat? No, it doesn't repeat. Does it terminate? Yes. Okay, root 2. That's a funny one. What happens with that? The square root of 2, we should all know where that button is on our calculator. 1.41421356. Do you think it just stops there? Or is that just all the digits my calculator is going to give me? It's the latter. It doesn't stop after 2. It keeps going forever and ever and ever. Whoop. 1 point. This thing's not being very nice. 4142, okay? And other stuff. Dot, dot, dot. Let me get rid of these. Okay. Correct alternatives for this guy. Does it repeat? I don't see anything there that repeats. Does it terminate? No. Does not terminate. Okay. That's pretty much our 3 choices for decimals. What else could possibly happen? Okay, either it terminates or it doesn't terminate, but if it doesn't terminate, it repeats, or it doesn't repeat. Can someone come up with a different situation on what's going to happen when we divide any fraction? Okay, here's some terminology, but I already kind of explained it. Okay, state whether this decimal equivalent of each one of these numbers is repeating or non-repeating. Again, how do you know how to make a fraction a decimal? Use your calculator. Put it in your calculator. Okay? So 1/8, if you put that in, you will find that will be 0.125. Is that terminating? Yes. Okay. Is it repeating or non-repeating? Non-repeating. My pen usually looks better than this, guys, okay? And so I got some static electricity or something going on here. I try to ground myself, but okay, still some strange things happen. Okay, I'm not going to go through and do all of this. I want to actually get into, what are we doing today? What was the name of this lesson? Is this rational or irrational? Let's get a definition. Okay? We need to know if it repeats or terminates. Okay? Because our definition says decimals which repeat or terminate can be converted into fractions, like the ones we just saw. These numbers are called rational numbers. Okay? Any fraction is a rational number. So if you know 1/2 of this premise, you know the other half. If it doesn't, then it's not. If it's not rational, we call it irrational. The best example for an irrational number is pi. Okay? That's this guy I have up on the wall here. He's going and going and going. Does it terminate? No. Does it repeat? No. No. Therefore, it's irrational. Okay? If it doesn't repeat or terminate, that's actually the two key words. Let's highlight that. Then it's irrational. Okay? Here's another pi. It's just got a few more hundred, maybe 1,000 digits. Okay? It never stops, never repeats. Pi is your best example for an irrational number. Okay? If it does repeat or terminate, it's rational. That's where you look. Because if you try to figure out both ends of it, you get all confused. Okay? If the number repeats or terminates, it's rational. Let's look at each one of these. Okay? I want to know if that's rational or irrational. How do I know if it's rational? If it repeats or terminates. Does it repeat? No. Does it terminate? Yes. It terminated. Therefore, it's rational. Okay? Rat. Okay? That's all you look for. Root 5. Does that repeat or terminate as a decimal? Do we know yet? No. We don't. How can we find out? Okay, put that in your calculator. Square root of 5. Let's see what happens. Does it repeat? No. Doesn't look like it. Does it terminate? No. You assume that it doesn't. If it's showing you 9 digits there, then you think it's got to keep going on and on. Just because my calculator goes 9, okay? So it does not repeat. It does not terminate, okay? It must be irrational because it doesn't do either. If it does one or the other, it's rational. Okay? Irrational. Make sense? This key word is or. It doesn't have to do both. Either or. Then it's rational. Okay? If it doesn't do either, then it's irrational. Does this thing repeat? Yeah. Therefore, it's rational. R. I don't need a calculator for this one. What's this as a decimal? Think bed mass, do the root before you do the subtraction. What's the square root of 81?
9.
It's 9. Otherwise known as maybe 9.0. Does it terminate? Therefore, it's rational. Okay? This guy, I have no idea. My calculator's doing something funny. Put that on your calculator. Tell me what you get. 4.41, 2.1. Okay, does it terminate or repeat? Yes is the answer. It terminated, therefore it's a rational number. Okay? Here's a weird one. These 3 dots, remember, that keeps going and going and going. You know it doesn't terminate. Does this repeat? Is there something repeats? 1, 1, 2, 2. That doesn't repeat because it goes 1, 1, 1, 2, 2, 2. Does that repeat? No. Doesn't do either. That means it's irrational number. Okay? That's supposed to say irrational. All right. Order the following on a number line. You guys know what a number line is? Well, there's one right there if you don't. Okay? So I got 5 things here. Okay? You want to make this a decimal, so you know where to put it. You put it on your calculator. What is the square root of 14? 3.74 something, something, something. I already know it's irrational. It tells me that. These say all these numbers are irrational. Remember, I told you pi was irrational, right? Where do I want to put it? 3.74. It's not quite at 4. About 3 3/4. That's where A is. Okay? Right about there. We all happy? Yes, because you're in math class. Pi. I'm going to say in the future, don't ever abbreviate pi. It's not 3.14. You should have a pi button on your calculator. That's the one you're going to use when you do calculations. But for this exercise, all we need is 3.1. Where's that? That's right about there. That's B. Okay? Root 80. What's that? I hope you know how to estimate that. That's 1 less than 81. And the square root of 81 is 9. So it's a little bit less than 9. Do we need to use our calculator? Good. We don't. C. 2 times root 15 is 2 times, what's this close to? What's the square root of 16? So this is just a little bit under 4. So this should be just a little bit under 8. Let's call it about 7.9. Everybody happy? Well, okay, if we're unclear, let's go. Put square root of 15 in your calculator, 3.87, but I have to times that by 2, and I get 7.75. If you can estimate that and come up with 7.9, that's awesome, but if you can't, use your calculator, okay? Looks pretty close either way. Lastly, the square root of 0.1. What is that? Not 0.01. 0.31 is what I get. Okay, or 0.3. Where do you put that? Is that bigger than 3? Is it less than 1? Yeah, it sure is. That's almost a third, right? Which is like down here. Okay? They're ordered. That's what it asked me to do. That's what it did. Okay? So, a couple of skills here. Irrational, rational, what's the difference? Know how to put some of the stuff in your calculator. This says again, 2 times the square root of 15. So if you have a good calculator, you can just put that in as 2 root 15 and get the right answer. If you got a Cracker Jack special, then you got to go root 15 equals, which you might go as square root 15. Some people's calculators, you go 15 square root. Then multiply that by 2 or double it. Okay? So you should all know how to do this on your calculator. That's it today. Okay? Shorter lesson than last day. Take advantage of it. Finish this assignment. Again, you got a quiz tomorrow, right? I want to just point out one thing after I attempt to write this. For number 5, because we're skipping all this, guys, if you can do that, if you want to read that, feel free, but we won't need to do that in this course, okay? Convert longhand, how to make a decimal a fraction, but if you get bored, hey, feel free. Number 5, it says identify which is rational or irrational. Okay, that's what we want to do, so we're not going to do this. Because some calculators, like mine, it can convert a decimal to a fraction, but most of yours can't, and if it does, you probably don't know how to do it, and like I said, don't worry about it, okay? So don't do the second part of 5. Just do, is this a rational or irrational? Okay? So 1 to 5, 9, and 10.